There were people who were concerned about the potentially corrupting influence of venture capital in the community, that might lead to where you have a secret cabal of developers working on things, and every now and then they'll put up a pull request, but you don't really see, you have no visibility into like what's going on in their heads, like what are they planning, like what's motivating this work that they're doing.
Were there any major growing pains that you had? I would imagine that there was probably not the most smooth sailing the whole way.
There's that push-pull between progress and being willing to break things and say, hey, maybe, it's okay. Like we've warned people that we're going to break this for several years. Like maybe it's okay that we break it now.
Open source is a lot more of a spectrum than I think a lot of people believe. Like the access to compute and the access to specific data is what I believe to be the major thing that's holding open source back. Is that a solvable problem for open source?
That's a very good question.
Wes, welcome to the Ken's Nearest Neighbors podcast.
Thanks for having me.
Yeah, I'm so excited to have you on. Obviously, you're working with Posit now, but you're synonymous with Pandas and the creation of the beautiful tool that I've used quite a bit over the course of my career as a data scientist. I would love, just to get you a little bit more familiar with the audience, to hear about how you first got interested in data and maybe how that's played out into what you're working on now over time.
Yeah, it's been a pretty wild ride up until now, but I've told the story back in many conferences and many conference talks and podcasts and things over the years. But the basic idea is that I studied pure math in college, and I got a job in quant finance like right as the great financial crisis was starting in 2007. And what happened during that era was that there was like a huge amount of stress and pressure to be able to analyze data more quickly and turn around research results that you could use to react to what was happening in the markets. And so not just where I was at AQR, but also like across the financial industry, there was this realization that we need to make the tools and the programming tools in particular a lot better, so that you can look at data, get access to data, manipulate the data a lot more easily. And in my case, I was under a lot of pressure and trying not to get fired, basically. And we were writing a lot of Excel and SQL and a little smidgen of R. This was pre-R Studio back in 2007. And I discovered Python, and I thought, wow, this is a really great scripting language for doing basic stuff, interacting with text files, CSV files. Like, what if we had some tools to do data analysis? Like, what if I could make myself more productive at work using this programming language? But there was a missing tool set for doing those data manipulations, working with time series data, all the basic table data operations, data frame operations that you would find in statistical computing languages, in R and in other places. And so it started out as a skunkworks that I didn't even have permission from like my boss or anyone I was working with. It was just my personal tool set. And I started socializing it with my coworkers. This was in 2008, late 2008, early 2009. And then at some point during 2009, I realized that what we had built at AQR, and at that point, like some of my colleagues there had started helping me with the project. I realized that what we had built had a lot of potential value in society by making Python more useful for data analysis more generally. And so I started talking with my bosses about, hey, can we open source this? And, financial firms are not known for being the most charitable when it comes to open sourcing things, especially in that era. So long story short, after about 6 months of me, whining and complaining, they're like, I think they decided that releasing Pandas as an open source project was better than having me resign to, go and rebuild it from scratch. And, by the end, they were very enthusiastic about open sourcing it. And I gave my first talk to the Python community at PyCon 2010. So a little over 14 years ago in Atlanta. And that was my first exposure to the open source ecosystem. I got connected with John Hunter, who created Matplotlib. He also worked in finance. And so that was partly how we connected, because I was interested in meeting Python programmers who worked in finance. And John really took me under his wing and helped orient me in the Python community and taught me about open source community building, kind of looking at what he had done with building Matplotlib and what he'd learned from the NumPy and SciPy and the early scientific Python community. And so I had really great mentors and saw the value of open source community building, and really that set me on the path of figuring out how to rearrange my life to be able to do more open source development. So very intense period. I really worked pretty intensely on Pandas until 2013, and then it became a community project after that. And like I got busy doing a startup, and I had there were enough of a group of core developers had come out of the woodwork, people that I'd met and encouraged to get involved, and I was comfortable handing over the keys to the project to them to lead development. And so the development has been led by a group of core developers over the last 10 or 11 years. And so that's been really fantastic. I think it's a sign of maturity and progress in an open source project when the creator is able to take a step back and not have to like loosen your grip and like allow other people to step in and step into a leadership role. And and that's enabled me to go off and work on other projects, which is great.
I love that. And something that I find really interesting, something I'm seeing in a lot of different areas, is there's largely no new ideas, right? We're pulling from different areas and things along those lines. What were the models for creating pandas that were not related necessarily to Python? Were you pulling from just like your pure math background? What was the definite specific need that you were seeing to create this infrastructure?
Yeah. So I had some colleagues that were using R and that were doing statistics and modeling work in R. So that was basically they were doing linear regression, robust linear regression, getting data out of SQL databases, wrangling it a bit in R, and running some regressions to do some time series forecasting. And so I had that exposure, interacting with the developers who were using R. I got some R programming experience, and I'd also written a lot of SQL by that point. It's all SQL Server, so it was Microsoft SQL Server, and I'd used spreadsheets, and I had a math background, but I also was learning about the ethos of the Python community, the Zen of Python, the ideas like practicality beats purity. Like there should be one and preferably only one obvious way to do it. And so, we started kind of looking at things that were hard to do in my work for my job. Like I really developed this mindset of like, everything must be really easy. Like it must be like, if we can get this down to one line of code that's easy to write, easy to reason about. And I think this has driven like a lot of other projects in the Python community, just this concept of like, it needs to be easy. It needs to be obvious. And so that kind of push towards both being pragmatic and not overly wedded to technical purity and making things really easy, that kind of became like the zen of Pandas development. Now, of course, like data itself is very complicated and messy. And so as a result, Pandas has grown into a pretty large and complicated project because it's trying to accommodate like all of these different usage patterns of people doing data analysis. And so there's many different like shapes and varieties of data. It's, Pandas has become like one of the ultimate tools for, environments where you have high data heterogeneity, like the type and the shape and the structure of the data varies a lot from use case to use case. Whereas like there's some tools that are, only, they're more suited for data that's more like, the kind of data that you would find in business intelligence that you manipulate in SQL. You can work with that data in Pandas, but if you're working with financial time series data, you can do that in Pandas too. And so we tried to create like a very inclusive project that was open to adding new things that would help expand, like make the tent bigger and make it a tool that could bring in like a wide variety of types of users, if that makes sense.
Yeah, that makes a tremendous amount of sense. I'm interested, as we're talking about bringing in new types of users, bringing in and getting started growing. Were there any major growing pains that you had, early on? What were some of the challenges that you faced with building something? Obviously, it didn't start at the scale it is now, but going from something that you're just using versus a team using versus a whole community using, I would imagine that it's probably not the most smooth sailing the whole way.
Yeah, some of the earliest challenges were like in some internal design details that we were concerned with our relationship with NumPy and how important was NumPy compatibility or interoperability. And so that, led to, a bunch of decisions that currently the community is in the process of trying to unwind. So for example, how do we, how does Pandas take views, or how does it mutate or interact with data that originated in NumPy, for example? And so in the 2008, 2009 era, we believed that if Pandas was going to be used at all, it needed to have a high degree of interoperability. You need to be able to jump back and forth between NumPy and Pandas with as efficiently as possible and with as little difference in behavior. And so this led to designing for NumPy, but now fast forward 15 years, NumPy is not nearly as important as it once was, and a lot of people who use Pandas never need to use NumPy directly, or NumPy is only there even as an annoying detail. Sometimes you get NumPy arrays out, you're like, what are these things? What do I do with this? This doesn't this doesn't have the same functions and features that Pandas does. So that's definitely one challenge. What types of use cases we optimize for. So often, if you want to make something faster, you're making something slower in the process. And so choosing what things do we care about making fast? That was also a challenge. I think longer term, since I haven't been actively involved in day-to-day development since 2013, 2014, it's been led mostly by people like Jeff Reback and Joris van den Bosch and Tom Augsburger and others. There's kind of a whole cast of the Pandas core team that are super active maintaining the project. Mark Garcia has been done a huge amount for growing the international Pandas developer community, running documentation sprints and all those kinds of things. And I think one of the conflicts that I've watched play out, and I haven't gotten involved too much because it's better for communities to just work out their differences on their own, is the conflict between it's almost the similar to politics, the kind of the progressive camp and the conservative camp. And in the conservative camp, there's a lot of concern about backwards compatibility, supporting legacy code bases, legacy users. And we recognize that a lot of people who, there's whole businesses that are, Panda shops, top to bottom. And it's the basic tool that they use for doing all of their analysis and all of their modeling and statistics and whatnot. And so, but a lot of people don't have tests, rigorous testing and other ways to check that, whether they're using some odd corner of Pandas that suddenly now, there's a non-backwards compatible change that's going to break their models silently. And so there's a lot of concern about breaking or backwards incompatible changes. And that often is in conflict with making important design or structural improvements to the project that can address design shortcomings or other things that were decisions that were made a long time ago, but maybe now we recognize that this was a trade-off that was important in 2009, but in 2024, it's a different. We would make a different trade-off now. We would make a different decision now because the world has changed a lot. But still, there's that push-pull between progress and being willing to break things and say, hey, maybe it's okay. We've warned people that we're going to break this for several years. Maybe it's okay that we break it now. But yeah, that kind of back and forth over how much Pandas is in maintenance mode, just being stable and reliable and exactly the way it was several years ago versus identifying the things that are really going to make the project. I think more recently, some of the work has been oriented at improving memory use and especially working with larger data sets, given that's been a kind of a problem for the project, is that it works really well for small data sets, but when you have larger data sets, you can have out of memory errors on your laptop pretty easily. And the general wisdom is you should have 5 to 10 times as much RAM on your computer as the size of your data set. And so people sometimes are like, what? I have got this 64 gigabyte, RAM on my, MacBook Pro. Why can't I work with a 10 gigabyte data set? It's well, you can, but you have to be really careful because if you do X, Y, and Z, you're going to blow out your a system's available memory and have a bad time. So it's so I see the different perspectives there, and these are, I mean, as with any large open source project, these are the types of things that have to be negotiated and debated. And I think what the great things is all of the discussion and debate is happening in public. So anybody who's interested in the project can go on GitHub and see what the developers are saying. And thankfully, this community has, I think, a very, very positive, very positive tone. Doesn't have a lot of bad actors. I think people are pretty pragmatic, just like to get things done. Very rarely making ad hominem attacks on each other. You often, you've seen legendary examples of that from the Linux community. So I think it's a very cordial group of developers, and everyone's, very just wants to protect the users and get things done, even when they disagree. So, yeah, it's kind of like in the Ruby community, the mantra in the Ruby community is Mats is nice, and so we are nice. And I dislike conflict, and I people who are disagreeable in open source, I tend to try to avoid. And so perhaps maybe the reason the Pandas community ended up the way it is, being very collegial and very positive, it was also because if people showed up and they with a bad attitude, maybe I wouldn't have been so encouraging of their involvement in the community. And so the early people who got involved were people who were, running on the same wavelength and said, of the kind of, very down to earth, let's just, let's build features, let's get things done, let's keep our egos out of that and realize that we're all just people trying to build software, and we're all doing this as volunteers as well. Like Pandas is, one of the most successful projects that's been almost entirely volunteer based, that's had very little funding, very little corporate sponsorship. So I think in more recent years I've gotten to experience the many different models of providing financial support for open source development to tackle ambitious new projects, and it's that's a big can of worms there.
Oh, I bet.
This episode of Canzera's Neighbors is brought to you by Z by HP. HP's high compute, workstation-grade line of products and solutions. Z is specifically made for high-performance data science solutions, and I personally use the ZBook Studio and the Z8 workstation. I really love that the Z workstations can come standard with Linux or WSL2, and they can be configured with the Data Science Software Stack Manager. With the Software Stack Manager, you can get right to the work of doing data science on day one without the overhead of having to completely reconfigure your new machine. Now back to our show.
Well, something I'm interested in, you said obviously you were able to shape a lot of the early community and these types of things in the project. And then you move from maybe being more directed by you and a smaller team to being something that's broadly open source and worked on in a community. How do you make that transition successfully? I think we see a lot of projects go a little bit off the rails when there's a transition like that without as much of a clear vision and clear leadership. Is that something that was created by maybe some of the cultural elements you were describing before, or is there some other secret sauce in there?
Yeah, I think it did require mindful, being mindful of the potential risks that were involved. So there was, so I'll give you a specific example. So when Anaconda was founded, it was called Continuum Analytics in 2012. So they were founded in the beginning of 2012. And there started to be, for the first time, some significant venture capital in the Python world. So there, Anaconda has been over its lifetime has been a tremendous partner to Pandas. Has paid developers to work on the project, to do maintenance. But there were people who were concerned about the potentially corrupting influence of venture capital in the community, that might lead to perhaps a group of developers working in private on designing things or doing new things in the project and not explaining to the other developers, what they're planning or what they intend to do. And so you end up with this, and sometimes you do see this in open source projects where it's this one-sided communication where you have a secret cabal of developers working on things, and every now and then they'll put up a pull request, but you don't really see you have no visibility into like what's going on in their heads. Like, what are they planning? Like, what's motivating this work that they're doing? And we luckily, like, we haven't had too much of that, but there was a active discussion amongst the developers. Like, how can we inure ourselves? Like, how can we protect ourselves against the possible, corrupting influence of corporations, for-profit corporations getting involved in Pandas development? And I think that one of the things that really helps is just making sure that as much of your project communication as possible is happening in public. And even when it's tedious, that if you have a video call, that the call is as open as possible, that you publish notes about like what you discussed in the call. If you make a decision in the call, that you write up the decision and your rationale for the decision, and you post that in some kind of a public forum. And in more recent years, I've gotten involved in projects in the Apache Software Foundation, and in Apache branded projects, there's actually a mandate that all project communications be public for this exact reason, that, you want to create this safe space where corporations can collaborate with each other, especially when you have salaried developers, like people who are working on an open source project full-time or part-time, but definitely as part of their employment. And if you have like, Oracle over here contributing to this project, and Amazon over here contributing to this project, and Microsoft, and everyone, the corporate interests, like they have their their product managers and their internal incentive structure. You want to make sure that everyone's playing by the same set of rules. That if they're planning a big piece of work, or they're thinking about something in the project, that there's a burden that they articulate what they're doing, why, and they don't need to necessarily say why they're doing it or like what they're going to use it for. So sometimes you see people building some new feature and you look at it as curious, like, why do they care so much about this? Like, what is this for? And often, you don't know what it's for, but still there's an expectation that there is a technical argument explaining like, why is this useful? Like, why should this be a part of this open source project? Who else would this be useful for? And so I've really enjoyed the Apache way of building software projects, where all project communications are public, discussions happen in public, creating that kind of open dialogue where you're also, by being public and open, that makes it easier for other people to get involved in the project. Because imagine how difficult it would be if you have this open source project that you're using, you're interested in contributing to it, you show up and you're like, no, like where's the dialogue happening? So you realize that the dialogue's happening in private. And so, maybe there's GitHub issues and there's pull requests and stuff, but really, unless you're part of the secret club, like, you're left out. And so that's no way to create an inclusive community. And there's already like great inclusivity issues in open source and in the software world more generally. And so when you have like an exclusive environment, things happening in private, that makes it all the harder for people to get involved in the project. So I think in the case of Pandas, we stumbled into developing that type of culture, from the outset, just because intuitively to me it seemed like the right thing to do. But more recently with Apache Arrow and Parquet and some of the other projects I've been involved in, it's like more of like an explicit like part of the project charter that like this is the only way that we're allowed to work, and that in practice has made it safer, and it also makes it safer for corporations to feel comfortable collaborating with their competitors. And so you can have cloud vendors collaborating with each other on a project, like we've had like in Apache Arrow, like we've had developers from Meta and from Google and from Microsoft and from Apple, all collaborating in a project, even though like they compete with, different parts of their businesses compete with each other. And yet they all share this piece of technology that they use in their projects. And because there's this established way of working, like we can't have, Apple developers, working in private, or Microsoft developers working in private. There's a burden that they go on the mailing list or they go on GitHub and say, this is what we want to do. And here's why. There's a technical argument. There's technical merit for this work. It's been very interesting to learn about all that and see what works well and what works well and doesn't work well. But, open source has become a big business. And that's also, I think something I didn't expect to go so far down the rabbit hole of corporate sponsorship of open source. But at a certain point, I realized that as an individual, there's only so much I can personally do. Like no amount of heroics and, late nights and weekends, it's like, how am I supposed to have a life and a family and stuff if I'm, working 80 or 100 hours a week for the rest of my life to like engage in these open source heroics? Like it really, like, to scale myself and to scale the efforts of the community, like you have to recruit other developers. Developers need to get paid as much as possible. So there needs to be money flowing into these projects. So we have to convince corporations why they should be putting money on the table to fund the development of these projects, like why they should be donating money to, charitable organizations that fund open source development or provide grants for specific projects. That's, I think that has gotten a lot better in the last 10 years. And now there's, numerous active grant programs for open source work, and contributing to open source has become like increasingly accepted and standard way of operating in corporations. It went from being like something that's weird and something that, I'll never get my boss to let me contribute to this project or to like allocate, 20% or 40% of my time for open source. But now I think people have seen many examples of the value of doing something within the framework of an open source project that you depend on, as opposed to, building everything in house and maybe someday later throwing code over the wall.
So all of what you're describing there, it now makes so much sense how Posit fits into this for you. I was wondering if you could expand on that and decision to, again, it seems to align directly with what you were just describing there, but.
Yeah. So I met JJ Allaire, who founded Posit. I met him first in 2012, which is a long time ago now. And I knew some R, and I met JJ, and we were at the R and Finance conference. I was there as like the Python heretic. And so I met Joe, CTO of Posit, and JJ, and I was really impressed with what they had built with RStudio. And we got to chatting about just at the time, the struggle was, how do we get more people to use open source for doing data science and statistics work? And so we realized that we shared this mission of creating an ecosystem trend away from closed source computing environments like MATLAB and SPSS and SAS to open source technologies. So we really bonded over that in the early days. I think there was a lot of work to do to make the RStudio IDE and the R ecosystem more successful. This was before Hadley Wickham joined RStudio at the time. And so that was how we initially got in touch. And so shortly after that, I started a company, Datapad, and I stayed in touch with JJ for the next few years. And then in 2015, I started putting together an open source project called Apache Arrow, and the idea was to create a reusable infrastructure layer for sharing data frames between programming languages and building high performance computing engines that could power data frame libraries. And so Hadley had just spent several years building dplyr, and that was emerging as like a next generation API for data frames in R. And so I got back in touch with JJ and Hadley in early 2016 when we were starting Arrow. Hadley and I got together and built the Feather format, which was the first example of like really good data connectivity between Python and R. And so after a couple of years working on Arrow, kind of my big sponsor for Arrow development in those early days was 2 Sigma. And so I reached a point where I knew that I needed to scale up Arrow development. And Posit had grown. Posit's mission, building open source data science, but also building a sustainable business that can fund that open source work. And so I was really attracted to that, being involved. Like I wanted to find a way to be involved in that mission while also funding Arrow development. And so I spent, I met up with JJ and Hadley, spent a day with them, and we started kicking around ideas like, how do we, Posit was willing to put serious funding on the table to fund Arrow development and help with the R Python interoperability. Like end the language wars was the way that we were thinking about it at the time. But then we also wanted to create a structure where I could raise money from other companies to fund Arrow development as well. So that's what became Ursa Labs. And so this was like my first formal partnership relationship with Posit. So I was, so during that period, like anyone who was part of Ursa Labs was technically also a Posit employee, including myself. So they handled like the back office of Ursa Labs, and we were able to focus 100% of our time on Arrow development. Posit was the biggest financial backer of that work. And so we've had a long relationship now, and they helped me incubate the startup that I spent the last several years working on, Voltron Data. And so they enabled us to work for multiple years on 100% on Arrow development without having to take venture capital and be beholden to investors. And that enabled us to like learn about the ecosystem, learn about what's needed, like where we should like what are the opportunities before we decided to spin out and start a company. So after 4 years of working on that startup, I'd reached a transitional period in my kind of journey as an entrepreneur, and decided to come back to Posit in a full-time capacity. Also because the company rebranded from RStudio to Posit and expanded its mission to include Python and to become a polyglot computing and data science company. And I really wanted to be a part of that and help that succeed even more than it already has.
Yeah, well, I don't think they could have brought anyone on better to help push the polyglot kind of overall messaging and ideal forward. You're bringing with you and Hadley probably two of the most prominent people in shaping these two languages. And I think it's incredible that you're kind of both under one roof to be able to push them both forward together, which is fascinating to me. I'm interested if we rewind a little bit and talk about the open source versus closed source conversation. So in machine learning tools, in I guess like data organizational tools, and like in that general space, I think open source has overwhelmingly won in the terms of most data scientists I know are using Pandas, Polars, whatever it might be. They're also using scikit-learn and some of these other tools for building their models. When it goes to creating the pipelines, maybe there's some other tools that are being used, et cetera. But broadly speaking, more traditional machine learning is almost exclusively open source, unless you're in a Meta or a Google or an Amazon where they have internal tools. Sure. But as we're evolving into more of what many people would consider an AI age, it seems like privatized models are more commonplace. They're also more widely used than, for example, like Llama or something that is more open source. How do you see maybe that playing out, and what are the benefits or drawbacks to something that is privatized like this? And does open source even have a chance to compete with some of these behemoths?
Yeah, that's
a very big question.
It's a big question. I mean, if you think about like what are the motivations, or like what are the motivations or the incentives of the players involved? Like if you think about like what are the longer, like what's the longer term outcome that the major players in the AI machine learning space, like what do they want to achieve? And so I read this. I read this book recently. This kind of sort of new book. His former like Greek minister of finance, Yanis Varoufakis, and he sort of coined this term technofeudalism. And so the idea of like the companies, especially the cloud vendors or companies with like major cloud operations, like their goal is to create products and services that are so essential that they just have a large fraction of the world is like their serfs, so to speak. And so they are the new feudal lords, and they collect rent from their they collect rent from their vassals and their serfs. And so in a sense, like the cloud vendors, are like the new kind of like the new cloud landlords, and using their products and services. Like, we're, effectively, even if we are not directly paying, we're paying with our data, and our engagement is a form of rent that they collect. And so I think that's like one of the major motivations that drives like this use, is that, it explains like Microsoft's, kind of close involvement with OpenAI, is that, they want to create these essential products and services that people simply can't live without. And so that creates more or less an infinite rent stream, for these massive, multi-trillion dollar, the magnificent seven corporations. I even saw a joke the other day that like, it's like real world Dune is kind of likening the all the different concepts in the Dune books to, TSMC and NVIDIA and the kind of, AI, everything related to AI, where it's like the spice is like, high end silicon yeah. And so it's, there's a huge market to be, controlled and monetized there. So I think that that doesn't bode that well for, cutting edge AI being very open source. And I think that maybe components and pieces, like some of the frameworks that are used, I do think that many of the frameworks that are used to build and train the models will be open source. And I've been following pretty closely this new company Modular, which is Chris Latner's new company, building like a kind of a new inference engine compiler, deep learning LLM compiler on top of MLIR, which is like a layer on top of LLVM. And so they're delivering, that's their plan. They say they're going to open source, and I hope it's open source, and they say that they're delivering better performance than PyTorch. But the idea is that it's built as a hardware heterogeneous or hardware agnostic framework, so that you can basically, using compilers, you can generate custom, you can specialize to custom silicon, as CPUs change or new architectures. We're about to see RISC-V emerge as like the new dominant CPU architecture. So we want to be able to incorporate new hardware accelerators, new types of computing chips, custom ASIC processors into our machine learning and AI. I mean, one of the big themes of a company I spent the last several years working on, Voltron Data, was building hardware agnostic analytical data processing. So GPUs for acceleration, yes, but also we want to be ready for using custom silicon to accelerate AI, basically feature engineering and data analytic workloads for machine learning and AI. So I think the frameworks, I think a lot of the frameworks will remain open source, and will I think that the major players will contribute work to keep those frameworks open source. And I think that my guess is that they will release like enough like light versions of their models, or that they'll release just enough software to make it easy for people to become essentially customers of their cloud offerings. And so it will be very so it's, if you look at Microsoft, if the analogy would be, if you look at Microsoft's strategy around VS Code. VS Code is an open source IDE. It's amazing. It has all of these extensions. It has all of these integrations. So it's really eating the IDE space. But many of the services that integrate with VS Code, while VS Code is open source, many of the services and things that integrate with VS Code are not open source, or maybe they're open source, but they're only licensed for use, or they can only use the Microsoft Cloud services if they're being used within VS Code. And so it's an interesting strategy, because it's like, it's open source, but if you want the full experience, like you need to be a customer of, or like to use this or that, segment part of the VS Code stack, like you need to be a Microsoft customer. And so I think that given that AI powered programming, the Copilot use case is probably the most valuable and the main use case for LLMs that will survive the current AI wars. This is very relevant, because who's building and controlling the environments where we're doing development? Ultimately, yeah, we should be. I use VS Code. I think VS Code's great. I think Copilot is great. But what things look like longer term, it's a very interesting question. I think that AI powered software development, AI powered data analysis is clearly like what the future looks like, and who controls that, who profits from it, and how much agency we as individuals have over being able to change and manipulate these environments or contribute to them without necessarily being a part of one of these companies that's building and maintaining the software is it's a very big and kind of interesting question. But again, I think follow the money. Who's profiting and who wants to, how, in what way are the kind of the massive, cloud companies creating these defensible kind of rent streams from data that they're generating, whether they're monetizing that data or whether they're leading to, I think, corporate clearly like enterprise subscriptions to LLM powered work services, data intelligence services. It's like I've heard that term the other day: data intelligence versus artificial intelligence. It's like almost a better term. It helps understand better, like, okay, like, why are they making this decision? Oh, okay, this because this will lead to like more defensible and future-proof revenue streams for these companies.
Well, I hadn't originally thought of it. You sort of prompted it in the conversation, is that open source is a lot more of a spectrum than I think a lot of people believe. You have all these different companies with varying levels of openness. Microsoft, you described, they completely changed their tune. They used to be quite the opposite, where, hey, all of our stuff is privatized, you're going to use it, and it's only going to operate in our ecosystem. You have Apple that sort of does that with their cell phone hardware, but from a like on their laptop operating system or their desktop operating system, it's a little bit more open source friendly than, say, a Windows machine would be. And I think a lot of people really generalize that to being black or white, where it's like, oh, they're a private company and they're doing this all over here, or they're an open source company that's viewing it widely as everyone can participate. And it's interesting to think about who will be successful in the long run with what models. I mean, obviously Microsoft is partnering very heavily with OpenAI, and Microsoft is probably, of the large tech companies, slightly more on the open source side, but the product that OpenAI produces is probably one of the most privatized ones. And I think that dichotomy is really interesting as we think about how the landscape evolves. Right.
Yeah, I think open source started out as Richard Stallman is still alive, but if he would be prefer. I mean, he will. Richard Stallman won't live forever, but I'm sure he will be rolling in his grave. Probably for eternity, because the free software movement hasn't. Like the values and principles of the of GNU and the free software movement, the original free software movement in the 80s, like hasn't played out like a lot of people hope, because open source was supposed to be about freedom to understand, freedom to modify, and fortunately or unfortunately, open source has become a go-to-market strategy. It's simply like, okay, like this is, having these open source components, and then, whether it's like to use the VS Code analogy, VS Code is open source. It's intended for like mass adoption, but there's like kind of a periphery of products and services that can yield revenue, from directly or indirectly from people using and adopting VS Code. And so, yeah, there's still plenty of purely community-based, community-backed open source. And so I think that will continue to be, it's important. It's even more important to, for projects that are truly community-led, community-run projects. It's important to support those as much as you can. So a really great book about this whole topic is Nadia Sparahova's Working in Public. It's like the book that I recommend to like anybody non-technical to read, Working in Public. And it's a great book, and it kind of demystifies the whole world of open source for like a business, like a general, like kind of somebody with business background who maybe doesn't know a lot about software development, because there is this enduring image of open source as being, unkempt, unkempt hackers on their nights and weekends, scraping together, some code in their spare time. But, the reality is that it has, since even since like the early 2000s has become a big business, and entire businesses that are based on, open source, open core products. Now there's a little more like, sort of things are a bit more in flux around licensing because of companies that have projects that they want to be available on GitHub. They don't want them to be like not stolen, but like co-opted by the cloud vendors. And like, there've been countless stories of companies having their lunch eaten by Amazon, or usually it's AWS. And so now there's a whole movement to like, AWS proof your project. They have these new source available licenses, which it's like, basically it's open source eventually. And so there's like a time, like eventually it becomes permissively licensed open source, and you're free to do whatever you want with it, unless you're Amazon, like unless you operate, a cloud, like a cloud service, at a certain scale, you can do whatever you want with it. So like the license is structured basically just to make it so that Amazon can't take your software and turn it into an AWS product. So that's created like a new dynamic kind of in the open source world. But it's very interesting. It's evolving still, and I'm sure in 5 years things will be different. Things will be different still. And I think right now we're in this transitional period, which, as you pointed out, Microsoft went from like the Steve Ballmer era of like, what, Microsoft open source, like absolutely not, to like embracing open source with open arms. But again, like, yeah, I don't know if Microsoft is still the most valuable company in the world, but it's sort of, it's like duking it out with Apple and Apple and Google. But open source is now part of it's part of the business strategy, and it's clearly working. And so it's yielded a lot of really good and nice things. But there's also risks involved with that. So I think as developers, we keep our eyes open, and I think at Posit, I'm really optimistic about JJ's vision to create a 100-year company, and to be kind of an enduring force for good in building open source data science tools and creating a sustainable business to support enterprises that are doing data science, so that we can make open source work in the enterprise and make sure we have consistent, that we have sustainable funding to fund these essential open source projects that make data science free and accessible for everyone.
Amazing. Well, I'm going to link Working in Public in the description and in the show notes for everyone. I think that's an awesome place to start to learn more about the open source communities. The last question I have is related to some of the challenges that open source sort of face. So something that I've observed mainly in the data space is that like the access to compute and the access to specific data is what I believe to be the major thing that's holding open source back, is that there's unequal access to these types of things, and there's exorbitant cost associated with them. In a perfect world where those were not factors in large language models, I think there would be dramatically more involvement and innovation in the open source space. Is that a solvable problem for open source, or is there like what would have to happen to make that less of an issue?
That's a very good question. On social media, I often see people joking about people being GPU rich and GPU poor. It's like, oh, I'm GPU poor, so I can't. It's like I can't do that. I think there's some tools and platforms emerging that are helping with expand access to GPUs for the GPU poor, or people that can't afford to buy an H100 because they're $37,000 or whatever. So one company that I've been excited about is Modal. So it's Modal. So that's Eric Bernardson's company, and they've figured out how to get like GPU job startup to happen with really low latency in a serverless computing environment. So people tinkering with LLM stuff that need access to H100s and are on a modest budget can run those types of workloads at reasonable cost on Modal. And I think there will be there's obviously like other platforms where you can get access to GPUs by the hour, with relative degrees of cost. But it's the hardware is in short supply and in very high demand and very expensive. And so the barrier to entry is significant. And so it does beg the question of like, who can hope to do serious things with LLMs outside of like, the most valuable companies in the world that have like massive capital to invest in, infrastructure and, can afford. I've heard about the cost just associated with doing training runs on some of these LLMs. And it's like, well, I mean, you have to have like, tens or, you have to have billions or tens of billions or hundreds of billions of dollars in revenue, for this to even be worth it. And so, how can anyone else hope to innovate, outside of that? And so, and it's not like things are getting, it's not like any things are any easier. Like I've also read about like how much the power consumption is going to grow over the next decade just for supporting the needs of running LLMs. Like, people have been, concerned and worried about, like the power consumption of the Bitcoin network. And like, it's like, I think compared to what's going to happen with LLMs, like if they're going to be more concerned about that in the future, like the carbon footprint of these data centers. So it's, I don't know that I have a good answer there, but there is a risk, and I think unfortunately it's the most likely outcome that like outside of the most valuable companies in the world, in China and in the US, that it just it won't be accessible. Like if you want to work on cutting edge AI, like you have to go work at one of those companies, which is they're the new nation states, in a sense. And so I don't know what can be done about it.
Well, I think there is some hope in the long run. So let's say in 2 years, we can dramatically reduce the cost where it's expensive, but not exorbitantly expensive. I think there's a massive incentive in open source to make things increasingly efficient. Whereas in these larger companies, if they have access to resources, there's an existing paradigm to just spend money to train.
Right.
And so there's some hope that, hey, like if we do things and we build, we work in public and we do these things, there's efficiencies that we can create because of the resource constraints that are there to begin with. Not saying that will necessarily happen, but I would imagine that there is a tipping point where it's like, okay, we have enough resources to be able, or like the costs have gone down enough where with the resources we have access to, we can start innovating very quickly because we're forced to. But right now, I think the amount of resources are so large that we haven't reached that threshold. But hopefully there's some crossover.
Yeah. And I think clearly NVIDIA's NVIDIA's status as the primary, like the main provider of computing hardware for these workloads. Like I wouldn't bet money that is going to remain the case. And I think that it's clear that like custom silicon for LLMs is coming. I don't know what the timeline is for that. I assume that people are already working on it, and it takes.
Sam Altman's trying to. He just needs $7 trillion.
Yeah. Yes, that's right. So I think that is like custom silicon is part of the solution. We have to worry about. I don't know if it's safe to talk about on this podcast, but we have to worry about like the geopolitical risk around TSMC and like where are those chips going to get fabbed. But yeah, I think the status quo where it's like, people are GPU poor and it's like just access to hardware, like that clearly has to change. And so it's good people are working on it, but yeah, I'm optimistic about where things are going. So more hopeful than full of dread, I would say.
Excellent. I think ending this on a hopeful note is really good. Wes, those are all my questions. Do you have any final thoughts, any words of wisdom?
No, I think it's we're in a really interesting time right now. I think the 2010s were pretty intense because we went through this era of like making open source work in business and getting so now suddenly like the Python ecosystem and open source data science is now the incumbent, and like it's like, of course we're working in Python and building things in Python, and like the language of AI and machine learning is all Python. And so it's great that we got all of that behind us, because it used to be that we had to convince people why they should be willing to run their businesses on this technology. So now I think moving on to how we can continue to improve the user experience, make things more efficient. Like a lot of my work has been, we didn't really get into it in this podcast too much. Like a lot of my work more recently has been about like modularizing and kind of helping like with the like horizontal integration, like having really specialized high quality components that solve different layers of the data stack, similar to what's happened with silicon, like kind of silicon manufacturing. It used to be that everything was very vertically integrated, and now cutting edge silicon manufacturing is very horizontally integrated. And I think the same type of thing is happening with data systems. And so projects I'm working on are oriented at helping with that problem. It's how to get, and partially that's like ending the language wars. It's like this idea of like the shared runtime, like a shared stack that we could use across all the programming languages, where we get, we make a performance improvement, we make something faster, we make something more scalable, and we get that improvement everywhere. So moving from, more federated and fragmented ecosystem to one that's more like working together and more focused on usability and user experience. I think we're getting there, but it's taken a lot of labor and a lot of time to make progress toward that. So I'm very excited about what's in store, the rest of this decade. And I think I definitely feel like I'm in the right place to continue driving this work forward.
Well, I'd love to continue that conversation in a later episode.
Sounds good.
Thank you so much again for coming on.
Thanks for having me.
It's a lot of fun.
Yeah.